All right, let's get started. I want to talk about JavaScript. Best time to ask a question or make a comment is when you have it. So please don't wait till the end. Anytime is a good time. So we'll talk a little bit about the pros and cons, and then we'll get into some nitty-gritty details. One of the, just to kind of start with, JavaScript is a very powerful language, and yet it's a language that's been written badly and rewritten badly by programmers code in that language. To an extent, it's really funny to really think back at JavaScript. Whoever thought this would become a very powerful, so popular language? If there was a guy who was programming in 96, 97, if he slipped and fell in a cave, and they just recovered him in 2013, and his first curious question is, what language people are excited about? And then the rescue crew says, well, JavaScript, of course, right? He has missed a beat in all the years that he's been away, right? It's kind of like a bad villain in a movie. They try to kill him and he keeps coming back. So in a way, JavaScript is all that. One of the problems, so there was a tweet, I thought this was a really funny tweet. And somebody also showed this to me a couple of weeks ago when I was visiting their office. And they have a bookshelf. On the bookshelf, they have two books sitting next to each other. One book is that thick. And that book is called Definitive Guide to JavaScript. That's everything you can do in the language. And next to it is the book that is that thick, which is called the JavaScript, the good parts. And so this is all you can do with the language, and this is all you should be doing with the language, Douglas Cockford's book. And JavaScript is a language which has a lot of inconsistencies in how it is treated by various different browsers, different environments. It's a language which is very poorly named. If you can just walk in a little bit and close the door, that'll keep the noise out for us. So come on forward. Keep coming forward. There are two seats here, and there's another seat here. So at least 3 seats if you want to come to the front. So you can move this chair a little bit. You can sit in the front. There's 1 seat here as well. Language which is poorly named. What has this got to do with the word Java, right? So it is fairly misunderstood, misguiding in a lot of ways. It's a language which is often misunderstood. I've had programmers use it for several years, and still they haven't understood the potential this language has. One other big problem with JavaScript is, how did most of us learn JavaScript? By looking at code on the web, right? And most of the code on the web that shows JavaScript is bad code. So we all learned from bad code, and no wonder we write more bad code. But of course, that was a few years ago. People don't write bad code anymore. They just copy and paste bad code today, right? So it's even worse than that, than it was in the past. But there are some really good things about JavaScript. It's a very powerful language, a little bit too powerful in a way. It is dynamically typed, but it's also weakly typed. So in a lot of ways, it's garbage in, garbage out. It doesn't do type validation at runtime. Unlike other languages, like, for example, dynamic type languages that run on the JVM, the type checking happens at runtime, but JavaScript doesn't do that. So it's dynamic and weakly typed. It's very flexible. It supports functional style of programming, but in no way can we say it is a functional language at all. In fact, a lot of ways you can say JavaScript is a dysfunctional language for what it does in a number of ways. And it's a language which supports functional style, but doesn't enforce immutability. So it gives us the higher order function, the closures. But the point that excites me the most, and I want to spend a bit of time here today, is the way it treats inheritance. It's a prototypal inheritance language, which gives us a lot more flexibility for inheritance than we are used to. And this is the charming part of JavaScript, in my opinion, but often underutilized also. But let's start with some ground rules before we go further. JavaScript, a few things are optional, but be very careful what this word optional means. It is optional as in, if you forget it will hurt you kind of optional. So it's important to be careful about using some of these things. So let's start with a little example and see how this is going to look like. For example, semicolons, right? So we could start with a function. Let's start with a function called foo. Now, anytime you give a talk on programming, you're required to use something called foo in it. So I've cleared that requirement in this talk. So let's say we have a number that's being given to us. I could say if n is less than, let's say, 5, I want to simply say return maybe just n times 2, let's say I want to return n times 2. So I'm going to say return n times 2 in this case, and if n is greater than 2, let's say 5 for example, what do I want to do? In that case I want to simply, let's say, return n itself. Let's try this out. So I'm going to go ahead and use this here, lower the font a little bit. So if I want to go ahead and use this, I could call foo, let's say I want to send a 6 to it. So 6 is of course greater than 5, so it should return 6 itself. And in fact it did. You can see the output that showed up as a value of 6 over there. So that's working, right? But what if I really call this one more time, but this time I call foo and send a 3. Well, 3 is less than 5, so obviously it should come into the if loop, if part, and then it should give a 3 times 2, isn't it? So I'm calling this foo with the 3 value. But look at what it did. It gave us an undefined. What's going on? Well, it turns out that we kind of split this into 2 lines. I could have omitted the semicolon here if I wanted to, but didn't change any difference. What JavaScript does is it says semicolon is optional, but if you don't put it at the right place, we'll do you a favor and I'll put it for you. So it inserted a semicolon very conveniently there. So it's all the more reason to do a fairly decent amount of unit testing when it comes to JavaScript to make sure the code is actually doing what you're expecting it to do. So that's one thing to keep in mind. So semicolons are optional, but I would highly recommend you place them at the right place and also make sure that the code is behaving as you want it to behave. The second thing in JavaScript we've got to be very careful is in how we define variables. So for example, let's go back to this code again, and I have this function that I'm going to write. I don't want to pass any data to it. And over here, I'm going to define a local variable. Let's say value is 5. I want to print the local variable. And in this case, I want to just call foo, and it prints the value 5 because 5 is local. Now, foo is, of course, local variable called local is obviously local, not because I called it local. But what if I tried to print that variable here in the code? That gives an error, as you can see, right? The error, why? Because local is not available outside of this function. Obviously, it's within that. Now, on the other hand, if I go back here and I define a value for a variable, let's say we give a value aha equals 7, and I'm going to print this variable's value, right? So I print it right here. So when you run it, obviously I can't use the local here, so we'll remove that. Notice that it printed the value of local, it printed the value of the variable called aha. But then, what is the difference? So notice I put the var in front of local, but I did not put var in front of aha. So JavaScript looks at this code and say, oh, wait a minute, Venkat did put var here, but he forgot to put var. What can I do to hurt him the most? And it figures the worst thing it can do is to make a variable global, right? I mean, that's sinful. So it turns this variable into a global variable, as you can see, so I can access it outside. So in other words, if you don't mark a variable as var, then it becomes a global variable. Now, what is the consequence of that? The consequence of it is, A, this variable scope is leaking out of this function, but it also is that if you, in other parts of the code, you're using the same variable name, you just overwrote on that. So really bad things can happen in the code. So that's something you got to be very careful about. So the moral of the story is it's better to declare variables with a var. Now, how do you know that you're not doing this? In order to deal with it, it's probably a good idea to always use an option strict. That way the runtime will at least complain to you saying, hey, you forgot to put variable as a var declaration. Now, how do we write functions, by the way? Now, there are 2.5 ways to write functions. Let me say why it is 2.5 ways to write the function. What you normally see people do is the practice that you don't want to use. So most of the time, you would see people do this, right? You would see function foo, and then it would take a variable value, and then I could say here, foo called with, and I could specify the value that you called it with. And then you would call this function maybe with a 4 like this. Now, I recommend that you don't do this. And this is what you see most of the time, and this is the format, a form that I don't like. The reason I don't like this is that, let's go with this example for a minute. I call the function foo. Now I'm going to say function foo one more time here. And in this case now, I'm going to go ahead and say output calling foo redefined, right? And then I'm going to call foo again with 4 in this example. So notice what I did. I wrote foo up there, and then I am calling foo, then I am rewriting foo again, and I'm calling foo. Now, when you read this code, what do you expect this code to produce as output? Well, if you logically read this code, you would say, it should say foo called with 4, and then the second time you called it, you would expect it to say calling foo redefined, isn't it? Well, when you run this code, unfortunately, notice, it called calling foo redefined both of the time. Now, how did that happen? But before we say why or how it happened, let's give it a name. This is one of the nice things in our field, right? We'll do some really evil things, but we'll give some really soothing name for it, so it doesn't feel that bad. They call this hoisting. See how it feels really nice, isn't it? So you can say it's doing hoisting. So what does hoisting really mean? Hoisting really means you're messed up totally, right? That's what it means. So in other words, it really said, I'm going to declare this variable called foo at the very top, but the value for it is going to be defined along the way. In other words, remember, when you wrote code in C back in time, you declared variables in the very top. Then when C++ came along, we said, we don't want to do that. We want to define variables wherever we are using them close to the proximity. Well, why did we do that? We said, because if you define a variable close to where you're using it, it's easier to see what it means. Well, in JavaScript, you don't do that. In JavaScript, you define the variables at the very beginning of the function, and doesn't matter where you're using. You say, wait a minute, but if you do that, it really becomes hard to see what this variable is if you have a very long function. Well, there's a very easy way to fix it. Don't write long functions, right? Then you can really see what these variables mean along the way, and that's kind of the practice we want to follow. Now, what happens in this case is it defines the variable foo at the very top, and then as you're defining this function, it keeps redefining that value. So in a way, you can think about this as a 2-pass execution of the code. So it goes through the code and says, what is foo? Oh, that is this now. Oh, wait a minute. We did redefine foo right here. So this foo actually is bound to this function here because of hoisting. Now, clearly, this code is confusing to my human eye, and I can make mistakes. So how do you avoid that? Well, one way to avoid it is to avoid defining functions like this. So I try not to define functions like this, and I would rather use the better notation, which is to clearly define a variable called foo. Now, to human eye, you really see that this is a variable you are creating right here. And then you say equals to function. I'm going to define this function right here. So right there is the function itself I'm defining. And how am I going to define this function? So notice now, we define that variable foo equals function. And then, of course, we are calling the function foo right here. Now I come back here and say that foo is equal to function one more time. And then now I am defining this new value, and I'm calling foo this time, right? So now when I go back and run the code this time, notice the behavior is what I really wanted it to be. And why is that? Because we defined the variable separately and gave it a new value. That variable is in scope with this current value. So when you called it, it was able to call that method. And now when you redefined it, it's very clear that you're giving a new value at this time. You are not using the hoisting at this point. There's an alarm going on somewhere. That's usually a normal behavior when you see code like this, right? So that's an example of how this actually is handling it. So is that somebody's alarm or somebody's brain actually kind of throwing fits? Right. So that's foo called with 4 as the first one. And then, of course, you're seeing that it called the new definition at this point. So this is a better way to write functions. That's what I would recommend doing. I said there's 2.5 ways to do it. Now, I showed you the first way, which is better to avoid. The second way, which is better way to do it. The 2.5 way is some people like to define functions with another name right here. So this is where you define a variable and assign to it, but you also give a name right here. This comes from the Department of Redundancy, by the way. So I recommend that you don't do this. And oftentimes people say they do this because it becomes easy to call recursive functions, but that's a big lie. So there's really not much reason at all to do this, and I recommend that you don't do, even though the code would work if you do that. So my recommendation is to use the var foo equals function notation. And if you do use this notation, it becomes more consistent in that you are able to use this function even as an anonymous function. So it's very clear that you created an anonymous function and you bound it to the variable foo. And then when you register events for event handling callbacks, which is something you do very normally in JavaScript, it becomes very helpful. Please.
One question. If you're also naming the function as suggested F1, does it mean that you could call both?
Yes, you could use either one, but F1 will have the hoisting and the variable foo wouldn't be doing that. Yes, you could use either name for that. But again, I would argue that it probably leads to a bit more confusion in that regard. Yes. Okay, so now let's talk about arguments to functions. This is really a charming thing. Now, how many of you program here in Java? Just for a quick poll. A few of us, quite a few of us. C#? So this is common to both the languages. C++? Okay, Perl? Did you say yes? Really? Just kidding. Okay. There's always one person, right? All right. So, Perl is special, by the way. Perl, you know what? Let's not talk evil about Perl today. All right. So, the beauty in all these languages we talked about, not talking about Perl here for a minute, in all these languages, we have a function definition. You can look at the function definition and it says, that's the parameters I'm receiving, right? So let's kind of work with an example. Let's say max equals function a comma b. And then I'm going to say if a is greater than b, return, let's say, a. Otherwise, return b. So I want to call this function. So I say over here, max, let's say, 1 and 2. And again, call this function one more time. This time, max is 4 and, let's say, 2. Now, when I run this, of course, it seemed to work. Now, I'm going to recall this method, but this time, I'm going to send a 0 to this method, right? So notice how I call this method now, function now, but I call it with 1, 2, and 3. But the function only took 2, a and b, right? When I run it, it still said 2. How did it know to work? Well, it's a little bit of a lie. If I go back and change it to 7 or 8, you know that's broken now. So what was happening? Notice, first of all, it did not complain to you. Why is that? Because JavaScript treats you like a guest in its house, right? When a guest comes over, you don't say, don't put it over there, right? You don't say that. You kind of smile at them and slowly move things around, right? So it's kind of like that. So JavaScript kind of doesn't complain to you. It says, that's fine. He doesn't know better. And then it kind of keeps going, right? So, but that's a good thing and a bad thing, right? It's a good thing because it doesn't scream at you. It's a bad thing because it doesn't quite work the way you expect. So what's going on here, by the way? What's going on here is that it really, so if you ask me, how many parameters does max take? The answer to that question really is simple. It depends on how many parameters you decide to send. So in this example, max takes 3 parameters on line number 7, and max is taking 2 parameters on line number 8. So in other words, it really doesn't matter what you put up here. So a way to think about this is, I could know the names of 2 people here in the front row, for example. Then I cannot just simply pretend there are only 2 people in the front row, right? The other people are going to be real. He's already staring at me. It's like, how dare, right? Yeah, so it doesn't mean there's only 2 people here. There are, of course, several people here, but it's just that I may know only the name of 2 people. So the point really is that you kind of gave names for these. Let's go ahead and get rid of that for a minute. And now I can still run the code. It doesn't behave as I would expect at this point. I can run the code. But in this case, what if I remove this for a second, and I still run the code? Notice it still ran. It's still undefined. So what's going on here? Well, now I can go back to this code. I can simply return, let's say, 1, for example. Just return 1. And notice this, both the calls are returning 1. So what's up with this arguments list? Well, I can change this a little bit more. And I can say arguments 0, which clearly is not the right result, but notice it returned a 1 and a 2. So what's going on at this point? Well, it turns out in JavaScript, it really doesn't matter what you put here. In fact, it doesn't matter whether you put anything here at all. Doesn't matter. The real arguments that JavaScript receives is referred by this variable with a special name called arguments. And arguments really refers to the arguments a method is receiving. So a really good way to get a variable number of parameters is how? Well, it turns out every single method in JavaScript always receives variable number of parameters. In the case of Java, you would use var args, right? In the case of C#, you would use params. You don't need to do any of those in JavaScript because every function receives a variable number of parameters all the time. So what I can do here is I can say variable large equals, let's say, argument 0 to begin with, and then I could return large. Now, I've not made any difference to the correctness of the code yet, but now I can say for I equals 0, I less than arguments dot length I plus plus, and then I can say if large is less than arguments of I, then I want large to be equal to arguments of I, and I can rewrite this code to return the correct result for me depending on what I'm passing to it. So if you notice this code now, we have rewritten it in a way we totally use the arguments. So it doesn't matter whether you put an A or B here. I can go back and put A and B here, and JavaScript says, fine, if that's what makes you happy, right? You don't have to use it. It doesn't really do any checking with that. By the way, just as a quick quiz for you, there is a flaw in the code I just wrote. Can you see what the error is?
I equals 1, you should start from there.
I equal to 1. Well,
Same thing anyway.
well, you know what? This always causes me confusion. Is this ground floor or first floor? I can never get it straight, right?
In this case, you can start from the second argument.
Because you assigned this over here. There's a name for this. It's called Premature Optimization, right? And that really increases complexity as well. And there's a reason why hair turns gray. And then you will get gray hair sooner than I do. You don't want to do that. But there's another problem here. What is it? Oh yeah, what if we don't pass anything? Yes, you're right. So if I don't pass anything max, and I just call without it, what's going to happen? It gives an undefined. Why does it give an undefined? Because he says, I went to the arguments collection, by the way, and there was nothing. So the argument 0 is undefined. Well, if you want to, you can handle this very well. Now, unfortunately, though, the word JavaScript has this word Java, and it has nothing to do with Java at all, except when it comes to exception handling. Right? So in this case, you can say if arguments dot length is let's say less than 1, you could say throw. What can you throw, by the way? Well, what can you throw in Java? Exception or throwable, right? In C#, same thing. But JavaScript is special. You can throw an object if you want to. You can throw a string. You can throw a number. It's kind of like being in a bad marriage. You can throw anything you want, right? There's no rules. So this is basically, you want to say throw, you sent nothing, we will come burn your village, right? So you can throw anything you want to. Now notice in this case it failed, and you can come back to this code and you can say try over here. And in this try, I can simply say, right over here, I could do catch. Now, of course, in the case of Java, you would put the type, and in the case of C#, you put the type, but here you don't have to. So we could just print the information, and you can see that it displayed the error. So that's one problem. You're absolutely right. Unfortunately, there is still a problem in this code. What is it? That's correct. So if you were calling this function from another function, and if that function had a poor variable named I, and that says ouch, and even more fun, call that in the outer loop, by the way. That loop is totally messed up, right? So that is why you got to be very careful with this variable. Very easy to forget. That became global. You're absolutely right. So be very careful. Anyway, coming back to this problem, what did we have so far? So we said you could be calling this variable number of parameters, and that's going to be the arguments coming in. So you can use the arguments very nicely, very effectively. Great. So we looked at arguments, and by the way, knowing about arguments is extremely important when it comes to JavaScript, because that gives us the power to write code in a very sensible way once we figure out what it does. Go ahead, please.
If we have to use an argument thing, so it will give us more flexibility.
Yep.
Then why there is a flexibility given to we can declare A, comma B, comma C?
Because that's more flexible. right? Meaning that you don't have to go through that effort if you really say, it's an 80-20 rule. If most of the time you're going to be sending only that many parameters, why go through the power of,
In Java, we have main. In main, we can only use R.
Yeah.
We are getting everything over there.
Sure.
So if we have to do it that way,
Right. But this is just any function, right? So then you are saying for every function you only have to use arguments. That's a burden. And there are times when you want to look at a function and say, oh, you do want only 3 parameters. I can send it to you. So it's a little bit of a specification as well to say, so you have the flexibility of both. And you don't want to say only you have to use this all the time. Then it really increases the burden of coding.
if I have another variable in my function name as argument.
This is evil thought. You shouldn't be thinking like this. You take a break, take a walk, come back in about 5 minutes. You don't want to do variable hiding. That's not a good idea. Right? Then you end up hiding the variable names and bad things can happen. Yeah. Say it again for me. Yeah, simply, you want to keep things simple. And such thoughts don't simplify lives. Don't do that. Yeah. No, you don't want to hide the variables. Then it will become hidden variable. Then you have more confusion around what you're doing. Now, we looked at arguments. Now, let's go back to this example. There's another thing that is very, very powerful. So let's say we have a function called greet. And the greet function takes, let's say, a name as a parameter. And within here, I'm going to say, for instance, say hello plus, let's say, name. So I want to call this function greet. And what do I want to pass? Maybe I want to pass, Raj to this. And then, of course, when I call this, it says hello, Raj. That's great. But why do I want to call hello? Maybe I want to change the message that I want to print over here. So I'm going to change that to, let's say, uppercase. And to uppercase on what? Some message. I'll say this dot to uppercase. Now, all of a sudden, I kind of snuck in at this. I run the code. It miserably failed. So what's going on here? Well, greet is a function. And to the function, you are passing parameters. How many parameters can you pass, by the way? As many as you like, right? Absolutely. But there is one more than many, actually, right? And that one more is an implicit object called this. So every function carries an extra pointer with it. And this pointer is called the this pointer. Now, when you think about it, this, what does this mean? Well, why do we create objects normally? We create objects because we want to reuse functions. Well, but if your goal is to reuse a function, why go through an object? Why not just go reuse a function? So in JavaScript, functions say, if you really want to reuse, absolutely go ahead and reuse the function, and I will run this in a context for you. So notice now I go back to this code. Rather than putting a parenthesis to call it, I'm going to use a special function called call. Now the special function call is different from the normal one in that you're binding this call to an object, and then you are invoking it. So here, I'm going to say hello, comma, Raj. And now you can see it said hello in uppercase, and then it printed Raj. So what is going on in this code? What's going on in this code is essentially the word this is now bound to the first argument you pass to the call method. So now I can say greet.call this time now. And now I could say, for example, bye, which is not a good thing to use because it's so happy Raj is leaving. But, but you can see that it actually prints that hello Raj, and it prints it. So of course it's a good idea to give a space here. So that is basically what's happening in this case is that the call method will take the first parameter as the contextual object, kind of like a delegate. And then of course the second parameter really is the real parameter. So in this case, this is bound to hello or bye, and name is bound to Raj. Now, this is good so far, but what if I want to pass multiple parameters? So I may say, for example, name1 and name2 as 2 parameters I want to send to this function. So I may say hello or whatever message, name1 plus maybe I want to specify name2. How can I call this? Well, I could say over here, this could be Jack, and I could be calling this with Jill. And so I have 2 calls I'm sending, and of course, it's say hello, Jack, Jill. Now, this is good so far. But there's one problem though. We normally in a web application, the data comes in a query string of some kind or a form data of some kind. So it's already in a collection of some nature with us. Now, if you have to split the data from the collection and then call them as these discrete values, it becomes very painful to code. So what you could do is you could have a collection of names, for example. So in this case, say, for example, I have Jack and Jill one more time. But this time, I'm going to say greet.call, and I could say hello, and kind of silly, but I could say names 0, and then names 1 to call this method. But that's a little extra work, isn't it? Instead, I can simply say greet in here, and simply call a special method called apply, and I would say hello, comma, names. And the difference is that while call takes discrete parameters, the apply method simply takes a collection of parameters, and then it would take care of dispatching those for you. So anytime you have a collection of data coming in, the apply will take 2 arguments. The first is the context argument, and the second is the collection of parameters that you want to pass to this function. So knowing about call and apply saves you quite an amount of effort when writing JavaScript. And in fact, if you look at tools like Prototype or jQuery, those libraries have been written to hide away all these complexities. But the problem a lot of times is when your code doesn't do what it expects to do, or you have to kind of go understand the code, it is very intimidating when you look at those code if you don't know what these things mean. But knowing that these are the concepts, it helps you to cope with these libraries a lot more effectively, but also to leverage these in your own code, it becomes a lot more helpful as well. So these are very powerful concepts. So we talked about arguments, we talked about the this, we talked about the apply as well, please. Very good question. So the question here is, if you don't use the call, and if you just only called like this with a hello, for example, right? Then what is the this? The answer to that question is a loaded answer. The answer that you don't want to hear most of the time is it depends. Because it depends on where you're running this code. It turns out today that JavaScript can be used in a browser. You could also use it in a server side. So the contextual object can be very different. So if I go back here and say print this, if you will, you can see that it's giving a very lengthy set of object. It's a contextual object. So it could be a global reference or another object. So it depends on the context in which you run. And a lot of times, knowing what that context is very helpful. So it's important to know. But the answer is it depends on the context in which you're running. I'm running all this in Node.js, by the way. But if you're running in a browser, it'll be very different. So it depends on where you're running it.
So it means that the user of a function should be aware that whether the function is using a this or
yes. So in other words, when you're about to call a function, it's a contractual binding. You need to know what you want to do with that function. To give you an example, I was consulting on a project where they were in a web browser, and then they would call into jQuery, and then jQuery would send an event back to their code, and the code would then start updating some of the fields in the DOM. But they would be specifying just the field names, and the confusion was, how does this code running here know the field names when the callback is coming from jQuery? So you can sit there and scratch your head, and they were like struggling to understand. And I said, wait a minute, what is the context of the this object? And suddenly the this object was the document object in this context. So what jQuery had done is, you pass a function, but it sets the document as the this object, then it calls it, so all the objects were contextually bound to this. Knowing that clears up so many things in your mind, but that's what sometimes libraries do. And this is another bag of tricks you have in your hand now. So when you look at functions, you would say, oh, what parameters does it take? Oh, by the way, what's a context object? Do I want to bind to the context object? Sometimes you'll see the call to bind. That's what they're doing when they call these things. That helps to know that under the covers. Now, let's talk about creating objects and classes. Yeah, please.
Can we somehow pose that a function which uses this within it? Can we pose that it has to be called via a call or an apply?
So the question is, can I force a function to be called in a certain way? The short answer is no. And the reason is, JavaScript is extremely flexible. It gives you the absolute freedom. But the freedom requires that we know what we are doing and we do the right things. And there is a few ways in which you can make JavaScript work, and there is almost infinite number of ways you can break it, right? So that is something we have to deal with. There's no real way to force it. And any try to force you are trying to introduce is only going to increase your complexity, and it's really hard to handle it. So the answer is that you kind of need to know how to use it. set up nice test cases around it. That's why testing JavaScript is even more important, right? Because it's so flexible that you want to make sure that it's actually doing what it's supposed to do. That's very difficult to control that. What about objects? So we want to create objects because we are used to object-oriented programming. Well, it turns out JavaScript is extremely object-oriented, as much as you want. In fact, in a way, it's better object-oriented than languages like Java, C#, C++ in a lot of ways. How do you create an object? Well, let's create an object, person equals. The language is so flexible that if you want to create an object, you just create an object. It doesn't force you to sit there and waste your time and effort creating classes. Of course, everybody in this room already knows what I'm talking about. We call this the Json object, right? So a Json object basically is a very lightweight name-value pair. So you can say first name, for example, and then you could say John over here. And of course, you can create a last name, and let's say this is Doe. And you can simply create this object. And now you can simply use this in your code, and you can say person. And you can see that it's a very simple object to create. A colon notation, a colon over here, because it's a property that you're creating. So that's a JSON object you just created. Now, of course, because it's an object, objects can have functions as well. So you could say work, for example, on this person, and then you can define a function. And this could be doing some work. In this case, I'm just going to say working. And we could come in and call this function. So you could say person.firstName, and then you could say print a person.lastName. But you can also say, for example, person.work and call that function as well if you're interested. So you can create fairly lightweight objects and pass them around. So this becomes much easier to transfer data between applications, between a server and a client also if you want to. But moving forward, I would say this is what we want to use mostly because I think the days of generating HTML on the server and pushing HTML to the client side is a terrible idea. You really want to go to a model where you want the server to be spitting mostly JSON objects or Eden objects, and then you want the client to be consuming that and doing stuff with it. So this is going to become even more powerful as you move forward. This is the direction we want to certainly go. So we can create objects very easily. But then you said, all right, but I really want to create a class. Can you create a class for us? Okay, let's create a class. So let's create a class equals. So there you go. I created a class for you. Happy? You're smiling, right? You're saying, no, that's not a class. It's a function. No, trust me, it's a class. If you don't believe me, look at it closely. Do you see this uppercase C? I know you got the joke. You laughed about it. In fact, that's exactly what JavaScript is doing as well right now. It's laughing, you humans, right? But this is called convention. Now I'm writing a function. You see that? Now I wrote a class. Now I write a function, right? So basically, if you use the lowercase, it's a function. If you use the uppercase, it's a class. Really? How so? No, not really. Every function is a class already. It's just that we didn't see it that way, right? So in other words, if you create a lowercase c, that is purely a function, meaning you treat it as a function. If you put an uppercase C, you are telling everybody around you that you don't want that to be used as a function. You want that to be used as a class. That's what you mean. Now, how does this really work? Now, before we go that route, we have to understand something else. So I'll step back for a minute. Now, let's get back to this person object for a second. Notice this person says, first name, last name. Let's remove the work from this function. So this person doesn't have any work method, and we called first name and last name. Now, JavaScript objects, by the way, have a special property. They have what is called a prototype. Now, what is a prototype? A prototype is kind of like this backpack, right? I kind of carry this around everywhere I go. It's in my back. And you can come to me and say, can I have change for 10 rupees? I would open my wallet and give you change for 10 rupees because I do happen to have it. But if you say, can I have change for, let's say, 10 euros, there is no reason I need to carry euros in my pocket. But I can reach into my bag, and it turns out I do have change for euros. I can get it for you and give it to you. So in other words, what I can do is I can reach into my pocket when I want to, but I can also reach into my backpack and look for stuff. Now, this is called prototype. So what is a prototype? A prototype is a bag of data, and every object has a prototype. But what's really cool about this is prototypes have prototypes, which in turn have prototypes, which in turn have prototypes until the last guy doesn't have a prototype. So there is a chain of prototypes that you have. And when you ask for something, it can navigate down and get it. This is extremely powerful model. Let's see how we can use it. So notice what I'm going to do here. I go to this class and say person.work, and notice this time it is going to fail because this person doesn't have a work method, right? It doesn't have any concept of work. Now, but I want this person to do some work. What do I do? So I'm going to say worker equals, and in the worker I create a work method. So I created another JSON object. And in this case, what am I going to set to this guy? I'm going to say function over here, and this is going to say working for a minute, right? So this says working, right? Now, notice in this case, I just created a separate object called worker, but then I come to the person object, and I say person dot, and I'm saying proto equals worker, right? I don't want you to use it this way. I'm just illustrating a concept. So you would rarely write code like this, but this helps us to see something that is going to happen under the covers. The worker has the work function. The person doesn't have a work function, but I attach the person's prototype to the worker over here. That's all I did. Now when I run this, notice what happened. I'm calling the person.work, but all of a sudden, the working is working, right? How did that do it? Because when I called the person, it quietly went down and called the work on the worker, because just like a few minutes ago I explained, if I don't have the money in my pocket, I can reach into my prototype and get it. Make sense? So this is prototypal inheritance. I haven't explained that word inheritance yet, but this is prototypal inheritance. But what does it do really? That objects can reach deep down and get things. Save the thought aside for a few minutes. We'll come back to it and see how that helps. So class car, and I'm going to create a class car here. So this is going to be car equals function. And in this case, I'm going to simply say creating. Now, obviously, you may say, can I do it this way? The answer is yes, but you don't want to do it this way. Why not? Because of the uppercase, we kind of hinted at each other that you don't want to treat this as a function, you want to treat it as a class. But if you really want to set this aside really clearly, in JavaScript, you don't create classes. In JavaScript, you create constructors. So this function you are seeing in front of you is actually a constructor. It's kind of like a factory, if you will. If you're used to programming languages like Scala, this is exactly what Scala does as well. In Scala, you write constructors, not really classes. So it's a very similar concept. But notice what I'm going to do now. I'm going to go back here and say var car1 equals new car. And at this time, I create a car object. Now I'm going to say over here, print car1.year. I want to know what year this car was created in. To do this, I'm going to pass this data 2013. Now I go into this function here. I'm going to say year. But that doesn't really tell me. It still says undefined. Why is that? It is undefined because I didn't set the year anywhere. So I'm going to have a brilliant idea. Year equals year. What do you think? It doesn't seem like that's going to work, right? And you're right, it doesn't work. Now, what should I do really? Haha, this dot year. Now, this notation is a bad idea in C# and Java. If anybody writes this, they have a private meeting with me in Java and C#. This one is, you have to do it. But put this in the context now. What's going on? So pay attention here. This method is very loaded. What it does is three things. The first thing, so when you see new car, what it does is the following, right? What does that mean? It does three things. One, that's very easy, first step, allocate memory, right? So that's the first step. That's what the first thing it does. Two, the second stuff it does is call the function with the memory as the context object. In other words, if inst is the reference to the memory, then tell me how the Java code is going to look like, JavaScript code is going to look like. Go ahead and try, don't worry about being wrong. You want to call that function car with the instance as the context object. How is it going to look like? Car dot what? Call, that's correct. Inst comma year. Make sense? So it, in other words, calls the object with the context object being the instance. That is why within the constructor, when you said this dot, it knows you're talking about this instance. That's why you're able to use this dot. So in other words, going back to your earlier question, the constructor is going to get called, but before that it binds it. And then the third step that happens, by the way, so the third step is set inst underscore proto to car.prototype. If you observe this very carefully, once the object is created, what's the relationship between this object and the car function? There is none, right? It is completely detached. So think about this as like the factory. It's kind of like the hospital in which we were born. We normally don't care, right? Some of us don't even remember where we were born, at which hospital, right? It's kind of like detached. And so basically the idea is your instance is created, it's bound to this variable, and then the constructor gets called. As the last step, the instance as prototype refers to the objects, the class as prototype, right? So in other words, the way this is going to look like is this. When you create this, let's say for a minute, car.prototype equals new vehicle. So I created a vehicle class. And in the vehicle class, let's say var vehicle equals function. And within here, let's just say for a minute, we have a turn method. So let's say we have a turn method here. So var turn. Actually, I can do this. I could say vehicle.prototype dot turn equals, let's say function, we'll just say print turn. So in this case, I'm going to say turning. So notice that in this case, because I have a turn method in the vehicle's prototype, and I attach the new instance of vehicle to the car, what does this do? The car1 has a prototype, which is car's prototype, right? Which is nothing but an instance of vehicle. So as a result now, I can simply say car1 over here. I can say car1.turn. I'm able to call that method. It says turning, notice that, right? So it's able to call the turning method. But let's take this a step further and understand something. Think about this for a second. I'm going to create two. What will those two instances of car have? They both have prototype. What is going to be the prototype though? Car's prototype, which is vehicle's object here, isn't it? What do you think? Does it make you nervous a little bit? So does it mean that if I drive one car, the other car has moved as well? That's called voodoo, right? You don't want that to happen, isn't it? So it seems a bit nervous. Let's think about this for a minute. Let's go back to this code for a second. What I'm going to do here is create two things. So let's go back to this code. And instead of turn, we will create drive. That's even better, right? So we have a drive function. And what am I going to do in the drive function? I'm going to simply say here, this dot miles plus equals distance. Give me a distance to drive. And this is going to be distance, right? Excellent. And what is this miles? This dot miles equals 0. All right, so far so good, right? So let's go to this car. We create the car in 2013. And we will say, first of all, print for me, for this car, print for me the car1.year. So let's start with baby steps, 2013. Let's print car1.miles. I want to know how many miles it's been driven, 0. Car1.drive, 10 miles. And now I ask him car1.miles, 10. Right? Now I'm going to say, right here, car2 equals new car, 2012, a little older car. And I'm going to print out car2.miles. So before the drive. So before we drive it, I'm going to ask him for car2's mile, car2.miles. So both of them are 0, right? We drove car1. I'm going to say car2.miles. What would make you happy? A 10-10 in the bottom or a 10-0 in the bottom? 10-0. But knowing that these two share the prototype, your mind says it's going to be what? This is like watching a horror movie, right? This is making you, does it make you nervous? Very nervous. So there's got to be something going on here, not sure what it is, right? So can you help me? Can you help me? Can you help me? Yes or no?
Yes.
Yes, what's your name, sir? Uday. So Uday promised to help me. You all heard that, right? All right. So you're my prototype. Excellent? All right. Now let's say for a minute, you want a change for 100 rupees from me. So I can give you change. You want to borrow 100 rupees from me, and I can give you 100 rupees. So I give you 100 rupees. Seems like a trustable guy, right? Is he a trustable guy? Seems like it. So a day goes by, and he gives me the 100 rupees back. And what do I do with the 100 rupees he gives me back? I put it in my wallet, right? Life is good. So a week goes by. He comes to me and says, hey, Venkat, thanks for your help last time, but I'm really in an urgent mode now. I really need about 10,000 rupees from you just now. You know what? We have a good trust now built up, right? I mean, I gave him 100, he gave me back. 10,000, what's the big deal? Oh, wait, I don't have 10,000 with me. What can I do? Prototype. Uday, please. So he gives me 10,000 rupees, right? He says, yes, okay. So I give it to him. A day goes by, very trustable guy. He comes back and gives the 10,000 rupees back to me, right? What do you think I should do? Keep it. Anybody has problem with it? I'm obviously not turning around to see Uday, right? Nobody has a problem with it, right? Yeah, he says no, yeah. I keep it, right? So if you understood what I just said, you understood how JavaScript works. Gets are deeper, sets are shallow. So in other words, when you go to an object and ask for a property, if it doesn't have the property, it goes to the prototype. If the prototype doesn't have the property, it goes to the prototype. It goes deeper to get it. But sets are shallow. You come to me and say, here's the value for and get the miles from this shared object. But when you go to this one object and set, the car keeps the value, the car instance keeps the value, not going to the prototype. When you go to the other instance, say, give me the value, he goes deeper to get it, but this guy has his own value. Next time you go to this guy, he's going to get it from here, right? So another way to think about this is that objects have properties, but properties may be shallow on them, or it could be deeper in one of the hierarchies. How do you know where it is? So let's go back to this example for a second. I just created this car right here, and let's say for a minute that I go into this particular object, and I want to know his properties. So I can say for, and we can ask a var prop in car1. And I'm going to ask him to print me the properties. So I'm going to say, what are your properties? Tell me what your properties are. He says his properties are year, miles, and drive. But notice how he conveniently said, you can come to me and say how much money you have. Quite a bit, right? Because I got Uday to back me up, right? He's a rich guy, and I can be giving out money as you asked me because I got prototypes to back me. But then you ask him, excuse me, got a question for you. Let me confirm, is this really yours or is it Uday's? Right? So now I ask him that property dot has own property, right? And I want to ask him, is this yours property, right? So when I run this, big liar. None of this is his property, right? False, 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 right? He says everything is from my prototype. I have absolutely nothing except for getting credit for taking the money. Right? So the point really is that it was deep in the hierarchy. However, notice that, let's go run this one more time. Keep this in mind. Now I say car1.drive10. Make sense? And once I drive this car, I ask him one more time, tell me about your properties, please. And when I run this, what is it doing? It's still saying false, but this should be on car1. So let me make sure I did this on the right instance. So this should be miles, and miles should have reported on car1. This should be, pardon me, I was wrong here, I was sleeping. So let's go fix this first. I was wrong. So this should be not on the property, car1.has own property. There we go. So notice in this case, the year was his property, right? Obviously because I put it in the car. But the miles and drive are not. But now if you notice over here, if I say car1.drive10, what's that going to do? It's going to set the miles value, isn't it? But now if I go back and run this sample one more time and ask him what his properties are, the result says that while Miles was not his property a minute ago, now Miles is his own property. Why? Because you have two instances with you. They both share the value in the prototype. And the minute you set the value in one of them, it's shallow, so it's here. But the other guy doesn't have it. It's going to get it from the bottom. This is how prototypal inheritance is done. So what is the benefit of that? The benefit is inheritance in Java, C#, C++, all those languages are static. What that means is you cannot change inheritance once you create it, right? You cannot do that. But in JavaScript, inheritance is prototypal, meaning I can refer to an instance and say, this is my prototype. And when you call a property on me, if I don't have it, I will pass it to it. But this is purely a pointer, isn't it? So along the way, I can quietly change my prototype and point to another instance. When you call my method, I don't have it, I'm going to forward it. Another instance can respond, and then I can quickly turn it back to the original. What is the use of it? The use of this is, imagine this for a minute. I am an order processing system. I need to process a credit card. So this is my credit card processor, so I put it as a prototype. You call process order on me, I go to the credit card processor and say, charge my credit card, please. Now you're saying, hey, I want to unit test this code. Oh dear, this is deeply coupled. Well, not so. In the unit testing, you come to the test, and you tell the object, hey you, I'm going to unit test you. So what do you want? I want you to quietly shift your prototype to a mock object. And you can call process order on me. I say process credit card, and all of a sudden it ends in a mock object and not a real object. And then when you're done with it, I can shift back to the original. Because of prototypal inheritance, inheritance is extremely flexible, and you can go back and forth as you please. So what I can do here is, I can come to this car and say, car 1, and I can change its prototype, and then I can come back and change its prototype one more time, and I can switch it back and forth. Or even better, in my test, I can just change the prototype. This one instance, and the original class still is pointing to its own prototype. So per test, I can start modifying things. Because this is so flexible, in language like JavaScript, you don't need a heavy use of frameworks and libraries and tools because it's so flexible. A lot of times the reason why you have these libraries and tools is not because the language is not flexible, because it is not well understood. But the more you understand a language, the less you would actually depend on these tools. Go ahead, please.
If two prototypes have the same method.
Yep. But you only point to one prototype at a time, unless you're going through a hierarchy, right? Oh yeah, but you always, if I have something, I'm going to give it to you, I won't ask my prototype. If the prototype has something, it's going to give it to you, it won't ask its prototype. So this is basically the way it chains together. But nothing stops you from saying, my implementation will check with my prototype. Absolutely, you can do that. And if you do that, you are using prototype to implement the concept of mixins or traits like in Scala. So a lot of these concepts have been borrowed from languages together, and you can implement something like that in JavaScript. By default, it doesn't do that, but you can build on top of it very easily.
So I can, my prototype has, say, another method, and the prototype has another method.
Yeah, you can combine them if you want to. The default doesn't combine it, but nothing says, oh, in my implementation, I want to check with my prototype, and then you want to run it. That's when you would set the context of this and do the call on it, rather than calling it directly. Go ahead, please. Yep.
I do a set and change the prototype. So the set variable is available in the instance.
Right. It will still go to your instance, not into the prototype, because you have set it over there. So that's what.
New prototype that
May or may not have it. Doesn't matter. But if that function is going to use that property, but if you change the prototype and it doesn't have that, it most likely doesn't use that property. So you wouldn't even use that in the particular context of the call. So hopefully that gives you an idea about the power of the prototypal inheritance and how you're able to put that to real good use. You can call properties using a dot property name. We saw that earlier. You could also put a square bracket and call it, so that way you can make it a variable name rather than binding to the name at the code writing time. And we also saw the has own property and see how we can use it. Once we kind of get a grip of these concepts, the way we program in JavaScript will be very different. We can really leverage the power of this language. It's extremely powerful, and most of the time people struggle with it because They haven't taken the time to understand some of these real core concepts of JavaScript, in my opinion. So I hope that that helps you to master this language. That's all I have. Thank you.